Mr. Mac here, and this is your 9-5 introduction in 5 minutes or less. In 9-5, we're going to look at 3 different key principles. The first is factorials. The next would be permutations, and then finally combinations. A factorial is a method of finding any number times each number less than it, all the way down to 1. So if I were to take a factorial of 6, I would write it like this. 6 factorial equals 6 times 5 times 4 times 3 times 2 and then times 1. You may ask, why do we want to do that? Well, remember, we're talking about probability. And sometimes in multi-stage experiments that are dependent, what will happen is the total number of outcomes will decrease by 1 in each stage. A good example would be that of a deck of 52 cards. And let's say I want to deal out all 52, and I go 4, 8, 10, Jack, 6, and I want to know what the odds were of getting all of the numbers that I get in the exact order that I get them. Well, what I would do is I would start off with 1 out of 52 to get that 4 of spades. Now my 8 is actually now out of 51 cards because I used up 1 card and never replaced it. Then I go down to 50, then 49, and then 48. And remember, as we go through a stage, we can multiply to be able to figure out all of the stages together, their probability. And so that's why something like this is extremely helpful. You'll find that on most of your calculators, that button. And what that does is it multiplies all those numbers from the biggest number all the way down to 1 together for you so that you don't have to do that on your calculator or in your head, one number in the sequence at a time. A permutation is a method of finding the total number of outcomes of a large dependent experiment when 2 restrictions are in play. The first is there are fewer slots than there are options. So instead of dealing all 52 cards, maybe I only want to draw 5. Because the game that I'm playing requires my hand to be dealt 5 cards. And then I get a 4, an 8, a 10, a Jack, and a 6 of each of these suits. And then I wonder to myself, what is the likelihood of getting a 4, and then an 8, and then a 10, and then a Jack, and then a 6 in these exact suits? Well, what I could do is I could, because I'm asking a question about the unique order being a unique outcome, what I could do is I could use my factorial, but I wouldn't want to do 52 all the way down to 1. I'd only want to do 52, then 50, 52, 51, 50, 49, and 48. So I kind of want to what we call truncate my factorial. That's what permutations allow us to do. There's also another special case that we'll talk about in class that has to deal with repeats. Now, a combination is a special type of permutation where order doesn't create a unique outcome, and so we have to take out all of those repeated outcomes that we did for a permutation when order did matter. That would be like saying that getting a 4, 8, 10, Jack, 6 is the same thing as getting an 8 first, a 6, a Jack, and a 10 and a 4. Most card games, it doesn't matter what order you were dealt the cards. It just matters whether or not you have the particular cards in your hand. And so, that would be more of a combination type problem. So mathematically, how do we figure each of these out? Well, first off, as we talked about beforehand, a factorial uses an exclamation point to indicate the factorial. And then the number tells you the number that you start with in the multiplication chain. So a 5 factorial would be 5 times 4 times 3 times 2 times 1. Now, to truncate a factorial, what we can do is we can start off with our number with a factorial, but then we divide by the number minus the rate, or R. The rate is actually the number of slots or stages. So this had 5 stages in it, so my rate would be 5. And so therefore, when I subtract my n minus my rate, then I'm actually going to be able to divide by all the numbers that I don't want to be in part of that multiplication problem. Finally, the combination would be, once again, where this order right here doesn't really matter. So I could have had them like this, and it's still the same hand. So to be able to take out all the different combinations that there are there, what I do is I just divide by R factorial again, and that takes care of all those repeats that would be in there. Once again, there is that special case where we're going to be using permutations to take out repeats for something like this case right here. But we're going to talk about that in class. This concludes your 9-5 introduction which was in 5 minutes or less.